Okay, we're here to talk about Chapter 5, Let Us Entertain You, of the Active Physics curriculum. A couple of reasons why we're going to start here. First reason is that whether you are using the old version of Active Physics, these smaller textbooks, sports, home, communication, or you're lucky enough to have the newer version, the much larger textbook, this unit's included in both versions. So this is some common ground we could work with and see how we break down the unit in Active Physics. So if we take a look at this and the task involved, it basically every chapter in active physics, every unit is wrapped around the challenge that students need to do, something they have to put together, design, plan, and then perform, basically. And this is going to be a sound and light show. Now, I know that seems a little bit daunting and possibly chaotic if you think about it, but honestly, it's not that bad. What basically is going to happen is students are going to either create some sort of musical instrument. If they're in a group, you might have a few students that made a few different things or work together on something. And if you happen to have some lasers or students have lasers, these are available at the dollar stores now, and small mirrors at the dollar store, very easy to get a hold of. They could also include, some cool laser light effects if they use multiple mirrors and reflect them off. And so it's not as bad as it sounds. The students do have fun creating their instruments and showing them off and putting together a little performance. So, give them a few days at the end of the unit to figure this out, put it together, and begin to work on this and prepare for that performance. So while we're talking about giving students time and time allotted, I do want to go over the pacing guide here, so you get a sense of how big this unit is and how much time is allotted to this unit. So if we take a look at the calendar, and so I'm going to show you where you find all this stuff. We're going to actually go to the BPS Weebly site. So if we look over online, we're going to go to, there we go. So we go over to the Boston Public Schools Weebly, and this is where you can find all the information that you need to teach these units. And we're going to go through some of this information together today, but let's take a look right here. We got the pacing guide, student learning outcome. And so we'll go down to the the physics pacing guide is here, and the pacing calendar, which I really like because this is a nice, colorful calendar that really shows you when you should be teaching a unit and how many days it is. So we see this is a pretty big unit here. It is about 23 days happening in December into January. And so this is last year's, but this year's will be up, and you could expect about the same amount of time, about 20 or so days. And students really need this time because they're going to be introduced to a formula. They're going to need to know how to master and manipulate the wave equation. And if you teach ninth graders physics, as most of us do, their algebra still needs some work. And so learning how to use this formula, how to plug in and how to manipulate this formula and solve for different variables takes practice. So that could often take a week alone. So before you know it, between learning how and getting the practice and repetition and then designing and performing their task, this will consume 20 or more days. All right, so that's looking at the pacing calendar. And let's look at the student learning objectives and what we expect students to get out of this. This, again, is found on the Weebly. Also on the Weebly, another resource I should mention since we're talking about why this unit's important. All right. Not only is this unit important because it's in both the old and new, but also there's quite a few MCAS questions on waves students will be up against. So you could see what the MCAS questions are by going to the Weebly and go into the MCAS portion, and you can actually search and see what questions were on the past. And you're going to see they align with the standards, and the standards align, or this unit aligns with the standards. And I'll show you exactly which lessons align the best and how to emphasize the concepts they need to know as we go through the student learning objectives. So this is a great unit. There's a lot of stuff students can relate to in this unit. Music and sound and light and waves is in their everyday life. So let's take a look at the standards here and compare to the student learning objectives here. And here we have 10 lessons in this unit. And I'll show you which ones we really need to focus on here. The first one is a good one because it gets them going, gets them doing some physics, and it's talking about string tension and affects pitch of sound. So they start to learn a little bit about what pitch is, and you start to relate that to wavelength and frequency. And you've watched my next video, I'm going to show you how to really emphasize that so we can really hit upon these standards here, especially 4.1. All right. And then make in waves is another great lesson. Do not skip it. You're going to spend a lot of time on this lesson making waves because, again, this really hits this very hefty standard 4.1 of the properties of waves and the relationships between them. And then sounds of string revisited. This is kind of a review of what they've done in section 1 and 2. So when you go through this, it's basically reinforcing what was done in section 1 and 2. So if you go through 3 and it's sort of repetitive, or if you don't have time, basically section 1 and 2 do cover it, but it is a good reinforcement lesson there. Sounds from vibrating air is good in that it reinforces the concept here of the difference between the transverse and longitudinal wave, standard 4.3. And so that's good to know. Students need to know that sound waves are longitudinal waves, and what is a longitudinal wave and how does that move compared to a transverse wave. So good lesson to go through and some things to focus on there. Section 5, shadows, honestly, I often, if I'm running short on time, this is one of those lessons you could skip. Not a lot of things that students will need to pull from that. Reflected light is important though. So section 6, reflected light, students really should be going through this. We see it in the standard here, section 4.4 right here in the standard. So this is something students need to know. What is reflection and what is refraction? Section 8, another important concept. So these two lessons, 6 and 8, are very important. Now, 7, curved mirrors, and 9, lenses. These reinforce the previous lessons. So 7 reinforces the reflection of light, and 9 reinforces the refraction of light. So if you have the time, you can do these lessons to help reinforce what was taught in section 6 and section 8. If not, you can skip. And speaking of skipping, section 10 on color, not a lot that students are going to be tested on, not really hidden on our current standards. So that's one of the lessons I tend to skip because it's near the end. And if I'm running short on time, it's not something they're going to be tested on per se. Although it is interesting, and if you have the time, definitely go through it. Okay, so those are the standards and the student learning objectives. Again, this is on the Weebly. Everything's on the Weebly. Please check the Weebly out. And as we continue to talk about this, I just want to let you know that next chapter 7, electromagnetic spectrum, hits upon that standard that I didn't mention, the difference between mechanical and electromagnetic waves. Very important. These sections kind of flow together, these two chapters. And if we look at the pace, if you look at the pacing guide online, again found on the Weebly, it talks about how you should add the Doppler effect in there in this section, okay? Because that is something, if you look in the standards, they need to know about, and it's not really addressed per se right here. So they put in the pacing guide, and I'm going to show you how the Doppler effect can actually be worked into this chapter 5. I want you to take a look at these websites and pause the tape, write these down, and then go visit them. And because as you're talking about the waves in these units here, all right, and as you're teaching about how basically refraction is a change in the speed of light causing this bend in light, you can relate that, all right? You can relate that to a lot of phenomena. You can relate that to sound. What happens to sound as it travels in different medium from a solid, a liquid, a gas? Okay, these are things they need to know. How does the speed of a wave change in different medium? And then you could start to talk about, since you introduced the pitch of sound and you talked about pitch, and again, check my next video on this lesson to see more of how you do that. You could start to introduce the Doppler effect, how there's an apparent change in the pitch of sound due to this apparent shift in frequency. And if you check those websites I showed you, okay, there's some cool things you could do and to show them basically how the Doppler effect works. Okay, so definitely check those websites out and check out my other videos that you could go to and see how to do that. And of course, do that close read in here. And there's a good Scientific American article, What Happens When an Aircraft Breaks the Sound Barrier, that you could really tie this all together with and get that literacy component.